Cloud. Okie doke. So what do we have? I'll go ahead and request.
Okay, what you're seeing here is the overall property, and I shared a couple of screens with you yesterday.
Uh-huh.
This thing, and this is a this is going to be an exemption from the subdivision ordinance. They have to do a minor subdivision, but they're going to end up creating 12 lots. They're going to do these first 3 lots as a minor subdivision, and then
Okay.
they're going to come back and do these 12,
Okay.
all as family conveyances. And this is one of my least favorite cases. This is a banking vice president who's decided he's going to make a fortune in the real estate business.
Oh boy.
And I found it's always better if you stay in your own lane and,
Yeah.
and do what you're good at.
Yeah.
In any case, because because he's doing so many lots, the highway department is going to make him do a plan and profile of a part of the road and do some drainage. And he's hired an engineer, Potesta and Associates, to do that. So I have to give them some topo, and I've created a topo sheet here, which is at a different scale. Let me go ahead and turn off. Well, let me just for a second. Let me show you.
There we go. Okay.
I shot. This is the highway. I shot both edges of pavement, and I shot the center line, and then I took it drops off steeply to a bank on this side, and I took a shot along there, and then I came back for a couple hundred feet back here. I picked out a center line. This, as you can tell from the rock outcrops, this is extremely rocky.
Mm-hmm.
And I picked out a center line showing rock free as much as I could. But once he gets back here and he puts this right away along this tree row, he's in for it, I'm afraid.
Yeah.
But, in any case, my goal today is to, and I just wanted to have this photograph on long enough to show you what we're doing here, and then I can turn it off.
All right. Now, one thing too to keep in mind, even though you picked out a center line, a potential center line, and surveyed that, you don't necessarily have to do that in the sense that if you can develop a continuous surface, then any center line you choose that lies over top of that surface, they'll be able to cut a profile from, as long as you've defined the surface underneath it. So
no, I just picked a center line to avoid the rocks
right.
I can see.
Right. No, I understand that, and it could have some different things, but I also want you to understand that you don't have to actually observe the center line to be able to develop a profile of that center line.
Okay.
As long, because all you have to do is have a contiguous surface, and then in the computer, any alignment you choose across it will develop its own center line. So so but you got some other benefits from picking out a center line. You know where things are going to probably go and all that. So that's good, but you don't have to in terms of being able to provide a profile all along that center line, as long as you have the surface defined around it. So
Okay.
okay.
So anyway, this drawing, because of the size of the and I went through and I created a cover sheet, which I have almost complete, and I have a sheet called the final plat of the McCurry minor subdivision, which shows the first 3 lots, and then I have the topo, which will only be submitted to the engineer. He's going to do his own plan and profile to submit to the highway department.
Right, okay.
And I picked out a couple of entrance points along here where I had, and in the northerly direction, you can see forever. You can probably
Right.
see for 1,000 feet, maybe 2,000 feet.
Mm-hmm.
In this direction, I picked where the site limit is, and I've got to give him those distances from each one of these. But anyway, what I'd like to do this afternoon is similar to what we did the other day. And I don't know if I did this. I don't have a scale here. I think I did this at 1 inch to 100 feet, which isn't a particularly good scale for topo. Oh, no, 1 inch to 50.
Yeah, okay.
And so that's not too bad, but because of the area that we have to do, I didn't think I could get it any, like I couldn't do a 1 to 20, I don't think.
Right. Just because it wouldn't necessarily fit.
And these things are huge, of course, and they don't need to be. I made them big when I did the original drawing to go out in the field and look for stuff so that I could see
Yeah.
them.
Mm-hmm. And no problem. You can change those at will.
So anyway, what I'd like to do today is to generate the topo in here, and then to bring in the topo from the state site and do a comparison.
Mm-hmm. You can also, Michael, look at your comparison and see how it looks. If it looks good, you can do your topo, which is going to be that little chunk around that entrance geometry there. And then you can merge it into the surrounding GIS derived or GPS derived rather topo that comes from the state. So you sort of tie in you've got the detailed part, they'll have the rest of it, and then you can cut profiles across, the whole site, across the whole state if you wanted. But
Okay.
But at least then that way you've got, though, the entrance down there is going to be much better defined than it will be from the flights. And that's what you're trying to deliver.
Okay, now I put all of the topo points on the 300
Okay.
series. Everything from 300 up to 350 is a point for elevation.
All right. So, and what about your spots? Will those also be?
Yes.
Okay, because that went up to like 390, I think. I thought I saw the number.
Maybe. And I haven't drawn any of those points yet because it's going to look so crowded.
Sure. Yeah. No, that's fine. All right. So
300 up to 350.
349, not 390. I thought I saw a 390. Yeah, so 350. So yeah, and so you can do there's a couple of things that I'm gonna have you do right away, because I want to use some field to finish to help generate some line work here.
Okay.
But go back to your points. Let's go to points and edit points. It's first right there. Now go to that group of points where they start, and you see the EP, those are fine. But what I want to do is like the ones that have spaces in the descriptions, like EP space P space ENT.
Yeah.
Go ahead and change those spaces to underlines. So if you'll just double click in there, and then there we go. Yep. And then do the same thing for that one. And then all the CL roads, whatever, you could even if you have no, excuse me, if you have no other center lines, you could just take out the RDs, the space RD if you wanted. Let's see,
Well, I could. That's probably the easiest thing to do. There are no other center lines.
yeah, so just do this, go to the edit menu, or it might be under search, but let me see what this is, edit. You look under search, do a replace. And you want to replace CL space RD, replace with CL. There you go, and replace all. Okay, now let's see what else we've got. Maybe a couple more EPs. There's toe and spot. I think. All right, so your best entrance is that one. No, that's a 340. It still is an elevation. So yeah, I would just give that a underscore. There we go. And that looks like it. All right, so let's save. Excuse me, we'll exit that. Excuse me. Now, let's go to your model tab because we don't really need to be over here in the viewport necessarily. Let's just go to the model. And let's do this. Let me double check a couple of variables here.
I check these settings to make sure the drawing's at the right setting.
Yeah, that's one of the things I was going to check anyway. So go ahead to do that. All right, so you're at 400. Yeah, there we go. Let's make that 50. Not 500. Not 500.
Oops.
There you go. And hit okay. Okay, and now I'm going to look at, there's a variable. MS scale. That is on, that's good. And that's good. Okie doke. All right, so we're ready to start doing our thing. So your final plat is the one where these corners are scaled correctly for 400 scale in your final plat, correct?
I don't think they even write it at the 400 scale.
Okay, so what
Maybe
is,
they are.
all right, so that's 400 now. Is that the right size for this plat, do you think? Or is that too big still?
Too big, I'm sure.
Okay, so there's a command. Much like, we could take this and see that it has a, we could find the block and see it's got a scale of 60. Which that looks like it's 500 scale. So 60 times 12 is 500. But anyway, is that right? Yeah, no, 50 times 12 is 6. Anyway, I don't know. Anyway, there's a command under settings called rescale drawing. And what this is going to do, it's going to ask this. Oh, it does ask the old horizontal scale, so I don't know what it was. Let's say,
And I just resized those points so that I could see them. I just did it arbitrarily.
yeah, oh, okay. All right. Well, anyway, I'll let you take care of that if you want. Are these all on the same layer like Platt, Roberts, and
Probably.
here's this one, which is on Boundary and Platt, Roberts. That's okay. So let's freeze that layer for now, or those two layers. Uh-oh. didn't want to do that one. I just want that. There we go. All right, so I'm gonna, and that layer that we just froze was this one down here called Platt Roberts. It's down here at the command. All right, so we'll remember to turn that one back on, and this layer is your geo image, and we can
Preset
that too, just to get it out of our way. Now, so what we're going to do is we're going to generate the 3D lines that we need to create the bit of terrain, 3D lines and spots. So one of the things that I would do up front, I'll let you drive here, is go to your points menu and let's make a group. And we'll just call this, you know, Topo group. So that's your point group manager. Go one right there. And we'll do create. And we'll change that new group to say Topo points or whatever you want to call it. And then, so down where it says include all, let's uncheck that. And we are going to include, you can either choose by point list because you know you're like 300 through 350, or you could pick by description, just in case we had to add any additional points at any point, you can change that. But either way, it doesn't matter. You can go ahead and make this point list. But if you do it by point list, and let's say you then add another point, you know, 999 that should be in that group, you'd have to go back and update your group.
Okay.
Otherwise, when you do it by description, as long as the description is in the group, then it's going to always be in the group too. So if you now uncheck the point list, there you go. Now go to your description. If you set from list, you can now scroll down and find. So I would just scroll down, you know, these start at 300. So we're, looks like you can sort, looks like they're sorted by description already. So just click one of the CLs. And you can click it even over here on the right hand side, like, well, you don't want that one. You do want one of those. And then scroll down here, and now there's an EP.
No, it's got them all.
Here, let's sort by name. I'm going to do that instead of by description. It sorts it by description purposely when you do this, because it thinks you're looking for, you know, you're going to pick them out by description. So we know we're going to start here with this 300. Now we're going to hold the control key down and click each one of these different descriptions that we need. See, we've already got EP, so we don't need to do it again. It doesn't hurt to do it again, but I only need one representative of each description. And I think I had that one. Did I get center lines already? Yes. Okay, so there's my center lines. And I got
I think there's another one above that we didn't get.
Okay, we'll go back. All right, so spot, center line, we've got that one. We've got spot, toe, EP, center.
You got it. You got it. Yeah.
All right. So now that will do it. And so any other points, if we have to add them at any point at any time, if we just call it an EP or CL or a toe, because this defines that list of that membership, then they will automatically get included. Now you have a 0.2 called center line.
Oh, that's actually probably okay.
Okay.
It's going to be probably close to another. I was doing that when I started out with the boundary.
Okay.
But it should be a good elevation anyway.
All right. So what we'll do is we'll see. And if it messes up any kind of thing like you probably shot it before you shot the first center line point that you were picking up.
Yes, it won't be in the right line.
Okay, so we're going to find that point and we're going to maybe we'll see if we can add it if it helps. If not, we'll exclude it. We'll
Okay.
be able to do that. Okay. So now we've got these points and we don't even really have to draw them. You can if you want to see them, but we can also do them through field to finish. So let's go to the survey module. And then let's go to the survey menu and choose field to finish. There you go. All right. So it wants to know a field code definition file, which you do not have as yet. So we're going to say new. And we'll leave it here in settings so that we can get to it anytime with any other project if we want. Maybe we'll use it as a starting point for something else later. So it won't hurt. So it's not going to go in our local job folder, but it'll be here in settings, and that's okay because we're going to name it McCreary, whatever this is called, McCreary.
Yeah.
Just call it, just in the file name, just call it McCreary. And then codes, McCreary space codes. That way you'll know what it is.
McCreary space what?
Codes, CODES. Yeah, it's just a description of what the file is, and go ahead and choose open. All right, so that's now the codes, and it says, you know what? Hey, I found multiple codes may have been found on a single point. And that's why I had you change those spaces to underlines.
Okay.
I didn't want them to be treated as double coded. But since we're not going to draw any of the other ones anyway, we're just going to allow those to stay, and we'll say go ahead and split all multiple codes. That's the way we normally treat field to finish, is we split multiple codes.
Okay.
All right.
Okay.
Yes, sir. And now the code table is empty, and that's fine. And we're going to edit the codes. Okay. Now it has read our points and found that we don't have any codes that match the points at this stage. So now we have several different things we can do. We can add and edit and do kinds of stuff and set up, libraries for trees and pipes and utility surveys, etc. But we're going to look under the section of buttons on the lower left part that says code table, and we're going to say code table by points. And what that's going to do is read the point file. And now, so we're going to say, here's a coordinate to field code definition. So we want a default symbol. You can go ahead and set, and I would use either a little plus tick or an X tick, one of those. That's fine. And remove any appended digits. I'm going to say no, we don't really want to do that. And that would be, oh, wait, I'm sorry. Yes, you do want to do that. What that would do is if you had like a CL, a bunch of CL points, and then you had another one, or let's say EP points, and then let's say you're surveying, over one part of the road and you're getting EP, and all of these EP points are to be connected together. But then you switch over to the other side of the road while the other side that you just were on is still in the process of being observed. If you go over and get another few points on the other side of the road, you want to call that EP also, then you would call that one EP2. Okay, so you'd get a bunch of points that say EP, and then you got some EP2, and so only the EP2 points will get connected together, and the EP points will be connected together. And if you had others like EP3, EP4, etc., until you close out the one you're working on. Okay, so that's why it says remove the appended digits. If you don't do that, then if you had numbers on the ends of the codes because you had surveyed it that way with that in mind, then it would make a new, unique, and separate code, one called EP, another called EP1, another called EP2, another called EP3, etc. When really all we want is one code called EP. So it's saying remove the appended digits, but it doesn't remove them from the description of the point in the coordinate file. It only removes it from the code it's going to create. That's all it's doing. So that's fine and what we want to do. So you'd want to append the current table or create a new one. We'll just say append, even though it's empty. If we said new, it would ask us to go pick another file. So we're going to say append. And so now these are all the things it found in the descriptions of our points. So what we're going to do right now is we're going to assign a couple of categories over there on the left. And this is an optional step. But you see the window on the left where it says unassigned and all,
Yeah.
right? So we're going to make a couple of categories. So just hit the plus button and let's make one called roadway. Just click in the field and there you go. We'll call that one roadway. We'll say okay. And you might have one, let's see, what else do we have? We have the TOA slope. So just hit one and call it slope. And if you had, stream center lines, things like that, you might want to do that. So slope, and let's make one called spots or random points or whatever you want to call it. Things that don't, so you can have that. And you can also have things like, utilities. In fact, go ahead and say okay to that. Let's make one called P core for like property core or prop core, property corners, or monuments, whatever you want to call, monumentation, anything like that. There you go. And let's see, did you shoot any trees? I think you had some trees, right?
No, I did not shoot any trees.
Okay. What about utilities like power poles, water lines?
No.
I know. All right, so normally you would have categories a lot, like those types of things. So now if you look at the unassigned or all button, you're going to see, let's look at the all. Right now they're all unassigned, so it doesn't matter. So yeah, just that's fine. Stay on the unassigned. Now let's take you've got cluster average. Now remember how we split the codes?
Yes.
So it thinks there's two different codes, one called cluster, one called average, and that's okay because we're not going to do anything with these. But just for yucks, we know the cluster average points are typically your property corner points where you're trying to establish those, right?
Right.
So let's click once in cluster, hold the control key and click once in average. And then yeah, let's go down. And what else did we see? We've got there's an RE.
Concrete monument.
Okay, so click that. Control click, I mean. Okay, and anything that might be like a property corner kind of thing.
Well,
there's the number 5 CRs and your SHEPP points and all that kind of stuff. And it doesn't matter. I'm just showing you what you would normally do to this. Don't worry about making sure this is complete. I'm just showing you the idea. So at this point, that's probably enough. And now look at the buttons in the underneath the table there on the right in the center column. See where it says move category? Right up, go back up right there. Click that and let's put that in prop core. Put the ones we have selected into prop core. Go ahead and say okay. Okay, so now they're out of unassigned. And if you click on prop core,
Okay, I see some others that probably should go there.
Yeah, that's like what is that? Like a fence point, or there's a
Fence
bound.
post, 5 inch, and W is wood. All
Okay.
of those found.
Yep. So
And
all of those, that's how you would do that, is you would just select them and control click them. Um,
A and C.
all right. So just
And all.
control click all that you want. Looks like you missed the A and C, but that's all right. You're shift clicking. You need to control click.
Sorry.
It's all right.
How about cluster and average?
Yeah, I would. And then I would, yeah, then I would say move category. Put those in prop core. You know what? It's not, I see what's going on. Let me see this. If I look at prop core, yeah, okay. What it's doing is when we just do it in the name, it's not doing it correctly. We need to click. Oh, I don't want to hit edit. See, I don't, but what I do want is the entire thing to be selected. So let me see, there's something wrong. So if I, well, I'll tell you, let me see if I just, can't really. So I won't be able to move them. Well, that seemed to work when I painted them with the mouse. All right, so FP5 WD6 found. That's it. Okay. All right, so you get the idea of how that part all goes. Now we've got and you could make one broad category called, topography, but we're going to have we've got roadway slope, so we're going to move that one to roadway. That's our center line. And we've got what else do we have? There's an iron pin. What's happened?
What are you trying to do?
I was trying to, there we go. Finally got the mouse back. Oh man, everything just locked for a while. All right, so I've got an iron pin, a concrete, a monument. So I'll now move those to property corner. All right, so we had the center lines. What is, here's some EP that go to roadway. We've got toe that goes to slope. And then we've got spot, and your best entrance points, are those on the EP, on the edge of pavement?
Uh, Two of them are, and one of them isn't. One of them's at the toe, I believe.
Okay.
I think.
All right, so I'm gonna just put both of those under spot, I think. And again, this part doesn't really matter much. Now, anything else in here, these are the ones that are left. See, I'm sitting here under unassigned on the left side. So these are the ones that have not been assigned. Or any of those make sense for any of those other categories?
Yeah, the capped and the rebar.
Oh, okay, that was
Wooden
rebar.
fence post.
All right, so let's go up here and get this. Now I'm selecting and dragging with the mouse because that seemed to be, I couldn't get the control click to do what I wanted it to. So I'm going to put those on property corner. So now that's, there was one more you said.
Wooden fence post, yeah, down at the bottom, those
Yeah.
two at the bottom,
That both of these.
yeah.
Okay. And you might, you might change the name of that to boundary or, um, deed points or any, anything that makes sense. I'm not saying that, and property corner may be perfectly fine, as long as you understand what's in those individual categories. And also, so that you are aware, they don't all have to be assigned. You can leave them unassigned. And field to finish doesn't care what category they're in. That's just a way to help you organize your points, just like point groups.
Okay.
So that's all that part is. Now, the way field to finish works then is that it's going to work on these individual codes that you have, whether you take them out of a category or unassigned or all, it doesn't matter. We'll just start with these. And it's going to look at the points that have that description, CL, and based on this code, it's going to start drawing things and put them on proper layers with symbols and line work if it needs to, etc. So what we need to do is to connect all of the centerline points in the order they connect, and we need to do them we need to generate some line work that are going to serve as break lines. Okay.
Okay.
So we're going to edit this point. We'll click that edit button. And I see, and here's another place where you can also assign categories. You can do all that kind of stuff, but here's the code. And I'm going to, for description, I'm just going to leave that blank. So it's going to create a point when it draws this into the drawing, and its DWG description will just be blank because I don't need it to tell me that. I'll see that it's in the center line, when I see the point. And it could also, if we draw the points here with the symbol, I'm going to actually turn the symbol off. I don't need to see the symbol, so I'm just going to choose that. Okay. And the line type. Now, this is something you're going to see this a couple of different things to keep in mind here. You can click and choose from your list of line types, in which case we have a center 2, which is a little tighter scaling. I'm just going to try that one for now. That's going to be a center 2 line, but that is going to, anything that it draws with this code is going to use that line style, regardless of which layer it goes on. If I choose a line style, that's what it's going to do. And also, these line types, these line styles are only going to be applicable to any 2D line work that gets drawn. AutoCAD, in its infinite idiocy, for some reason decided long ago, and they've never changed it, that they can't display 3D lines with a patterned line type. It's unfortunate. All the other CAD programs do it, but anyway, so that's why we have to draw these as doubles. If we want to get the center line to show up as a center line, we need to draw a 2D center line, at that location. All right. So that's if you choose a specific one. Now, the one I'm going to choose here, and I'm going to leave all of them set to this, is just by layer. That's more typical. And then when I put it on a centerline layer, I'm going to change the centerline layer definition to include that line type. All right, so that's all we need to sort of dig into on that one at this point. But the key right here is back on this general tab, we're going to look at a couple of layers, descriptions, names, and all that kind of stuff. Here's this full name, for instance, and I could type centerline points, for instance, like this. Now, this full name, the only thing it's going to do, and I'll go ahead and say okay to this, is it fills this out in our code table. Okay, it doesn't show up anywhere in the drawing or have any bearing on anything other than, again, just a way for us to sort of keep ourselves organized when we have a bunch of different codes and we don't remember exactly what they are. We can have it do that. Now, that's not an issue here. So most people just leave that blank anyway because they know what the code is. The description is what you want to show up in the drawing when you plot the point or the line work. Now, I don't need anything to be plotted other than just the center line. So I'm going to leave that blank as a description. And the main layer, and it's going to be, I don't know if we have any. You've got access road. Those are for points I can see there. Did we have any?
I have a highway, maybe.
Yeah, I was going to look there. Typically, if you start with so if you start with one of those like National CAD standards drawing templates, you get a lot of those like V-road centerline kind of stuff. And that's really sort of more the case. Now, here's a bunch of those are the proposed, those are the civil layers. So you got a C-pavement parking lot. So that would be, a proposed parking lot kind of stuff. That's just left over from a previous, there's a C water center. So you see that how that structure is. So what we typically would do is we would see something like a V-road or a C-road. And this is surveyed, so it's existing. So it's a V-road. And then I'm just going to call it CNTR for center line. And you could put CL. It's just naming convention. And you see these up here, and you see that -N on the ends of those. Those are from, in fact, I think this file must have started life. There's a company up in Buffalo that does that with their layer names. And I don't know for sure that this might have been the origin point for that layer name, but he always stuck a -N on there, meaning that these are my new things that I'm going to put on this layer. I never could get him to understand that the fact that you call it C- means it's going to be a new thing. If it's an old thing, it's going to be V-. He never could quite grasp that, but so no, that matters. But anyway, so I'm going to put this on V-road CNTR. And even though it doesn't exist, it will create it for us when it first processes. Now, so that's our main layer. That's where we're going to put it. And we look down here in this lower left-hand corner. What are we going to put on that layer? Sometimes it's points only, like if you've got fire hydrants or manholes or, things that are points only. Sometimes you want to draw a line, or my preference would be a 2D polyline, even if it's only a single line. And sometimes you only draw a 3D polyline, but sometimes you want to draw a 3D and 2D. And that gets into that option of where you need to, in your final mapping, you want to show those patterned lines and you want them to be 2D, so that the line pattern will show up. But you also need the 3D line to be able to do the terrain modeling. So you're going to draw 3D and 2D. Now, there's another reason why we do the doubles as well. And that is when we go to model the terrain, if we have shot EP and then an EPPC, where we're starting like at the edge of the pavement, we're picking up a curb return, we're going around an arc.
Yeah.
So we've got PC and then PT points. So it will actually generate a circular arc that we can dimension and label its radius and all of that. But to get it as a 3D, it can't create those as circular arcs. They have to be those little horizontal chords, those little segments that are done through that method of maximum offset or chord length that you remember from the settings. Okay, so that's the other reason that we want to keep them sometimes 2D and 3D is so when we do the actual platting, we're going to get the true circles. But when we do the modeling, we're going to be able to convert those to their elevated components and model from them, and then we'll freeze off the 3D lines after we're done. All right, so that's what we want with center lines. Edge of pavements, toe of slopes, we don't really need 2D because we just need them for being a break line unless you need to actually delineate the toe of the slope in your mapping, and that can be your choice when you do something like that. Now, once you've chosen 3D and 2D, you can come up here at the top and see we've got a main layer, a distinct point layer so that you can put the points on a particular layer if you want, and freeze that layer off. And you see what it does is it just it puts an underscore in P&TS on the end of our main layer. So I can then freeze the points and yet leave the line work and stuff that gets drawn turned on. Okay, so that's one reason you would do that. And then it asks you for a dual 3D polyline layer. And at this point, and again, you can say set, or I'm going to just call that 3D space BRKLN. And that's just my choice of a layer name. And that's what I always put my break lines on. And I usually, when I go back and once it creates it, I'll change that color to be something else, but whatever. And then the attribute format, that's where you can set the the labels for the points. Those are the point attributes. And if we leave the attribute block, it's going to just take our default point attributes. That's fine. Here's that layout ID. I'm going to switch it to that 2, which is, that everything lined up on the right-hand edge. This is just like in your points defaults. See, there's the standard default of 1, that kind of stuff. And you can put the attribute layers on separate layers, all kinds of things that you can set up here. We're not going to go into all the details. You can assign this to a particular point group. Now, we have a point group called Topo we've already made, but we could make another point group called road points, and it would only get, center line and edge of pavement, for instance, if you wanted to do that. So you could set a group that all the points with this code are going to go into. And here's our attribute size scalar. We'll make those just a little bit under a tenth. We'll call it 800ths. Allow annotative, so our annotative scaling could work. That's all fine. Elevation integers and decimals. Now that has to do with this integers is like if you want to strip off, let's say everything's at 5,000 and something kind of elevations, and you can, for making your map a little less cluttered, you can have elevations of like 232.56, and you have a note to say all elevations are 5,000 plus what you see. You may have seen maps like that. I don't particularly care for them because they're too easy to be confused. But anyway, that's what it's there to do. So we're going to do all. Number of decimals, any prefixes and suffixes on the elevation label. We don't need any of those. Whether we're going to locate the points on the real Z axis or not, yes, we will. And whether or not it is a non-surface point. Now, remember that 0.2 center line? We may have to come back and change it on a subsequent pass, because right now it's going to see 0.2 CL and it's going to draw to the next CL point it can find, and then the next, and then the next, and then the next. And that's okay. We'll see what happens and we'll fix it if we need to. But this is also a way, like if you have fire hydrant points or manhole points or things like that, that you want to put them on their elevation and you want to keep them out there, but you don't want them to be used in the modeling. So you could make, you know, maybe you're shooting the top plug on the manhole and you, or on the fire hydrant, you're not down at the ground. So you don't want those little, you know, spikes in your surface. So you would say, call that one non-surface. There's also a code that you can use individually on any given shot that you say, don't use this for surface. But anyway, that's the idea. We're defining the behavior of anything named CL. And then we have a feature type, whether it's topo, tree, pipe, or utility. Those are somewhat new. It's they're new still in the sense that most people don't use those, but there's a tremendous amount of power available in, if you're doing utility surveys or tree farm surveys and stuff like that. It gives you a lot of things that you can do, but that's for another day. Now, and all of these different codes down here below are not, you know, they're just additional finesse and definition. This is really all that we need at this point for our center line, and we'll say, okay. All right, so next is our edge of pavement. We're going to go to that edge of pavement. Again, I'm going to take the EPs off my symbol. I'll just leave blank. Line type, I'll leave it as it was, as by layer. And so here now is our, and you know, I could specify, you know, edge of pavement, again, for my reference, that's all that is for. And so I'm going to put this on this main layer, and this one I'm going to put on the road dash edge. Sometimes you'll see edge of asphalt. Sometimes you'll see the EOP, anything. Sometimes it just depends on the survey. Sometimes it's edge of gravel, sometimes it's whatever else. So we'll just call it EOP. And then we'll also have it put it on separate points so we can freeze the points separately. And we'll put this on the 3D polyline layer of, or the dual 3D, 3D break line, so that it goes on that same, and I've come down here and make sure I choose 3D and 2D line work. Attribute size, I'll set this one something to here again. Change these to 2, and you can set those up as some defaults instead. And none of that, all of that stuff is purely cosmetic, so there's nothing going on there that you have to worry about. But so I now have those. Now the EPPENT, we'll take a look at where that one comes in our flow of things once we draw it. And so I'm going to look at this. You see this description. So it's going to actually plot its description, and it's going to plot it as a point only right now. But let's put it on this main layer of V-road-EOP, just so we can see it when it comes to that. We'll also put the point there, but I'm going to leave this sitting here and with this default point so that we can see what it is, and we can decide whether we want to change the code later to see if it makes sense. Or it could be that maybe it really belongs in a spot type of elevation. So we'll see how it plays out. All right. So those are our road points, our slope points, excuse me. Our toe slope. And let's do this same thing, but I'm going to make a 3D polyline only. And I'm going to put that, instead of on toe, that's going to be a 3D BRKLN. So it's going to always go on my brake line layer. And then when I freeze the brake lines, it's going to go away unless I need to show that toe slope. And you let me know if you need to see that or not in your final mapping.
I don't think so.
Okay.
As long
So
as
it,
it shows up on the topo.
yeah. So and you understand that if you needed to show that, you would come down here and change this to 2D, 3D. And then that main layer would be where the 2D line goes, and you'd have this dual 3D layer that's now gray. That's where you would put this 3D brake line. But right now, all it's going to do is put these points on this layer called toe points, and it's going to draw this 3D polyline on this layer called 3D brake line. That's all we're going to have it do with that one. And again, I'll set those up here and say, okay. All right, so there's our toe points. Spots are just going to be spots, main layer. Let's call it D dash topo dash spots. I don't need to separate the points. I'll just have the points go on this layer itself, and we'll see the points as to whether or not they're going to go. And so we're going to draw those as point only. We're not going to connect any line work. And the symbol again will be that X, and you could have it separate. You can do a different one, say for a particular code. And so let's change this attribute to, I think it's that one gives that little angled up elevation. And let's make that as a 8 points only. There. Description, none. I don't want to see the description. I'll just take it as a spot elevation, and we'll say okay. Best entrance, and we're going to.
That was kind of like a spot that's labeled as
Sure.
best entrance.
Yeah, and so this would be basically just sort of a random shot. So we'll leave the symbol. We'll leave it to go on this own. Let's put it on V dash. Site miscellaneous, something like that. All right. And we won't put it on a different point layer. We'll do the points only. We'll do it 2, and we'll make that. And so we'll see what happens with that. All right, now we've got these others, which we're not, these are going to adjust because we're not defining them. They're just going to go on their own layers and all of that kind of stuff. If we were to include them in our group of points to draw by field to finish, you'll see when we go back to draw field to finish, we don't even have to include these. So they've already been taken care of. But we had roadway points we took care of, creating codes, slope, we created spots, and that's really all we need. Okay. Now, I'm going to hit the save button down here, but there's a couple of other settings that we have to look at in the code table. And if I click this code table settings, it's going to bring this up, and it brings up this list where we can change to a different code file if we needed, but this is the one we're working with. And then which coding method, and these are all different, land XML, Eagle Point, SDMS, and KC, split multiple codes. And right now it's prompting us to do it, or we're going to say, no, I want you to always split the codes because that's the way I want to treat these. And that's why you got one code called cluster, one code called average, et cetera, et cetera. Now, using multiple codes, because you could have a code, for instance, that is the edge of pavement out on the main highway, but it's the edge of a gravel driveway, for instance, or even a paved driveway. It could be the same point, or it could be the point of a drop inlet, but it's also the edge of pavement. So when you shoot that point, you only have to shoot it once, but you call it EP space INLET, or whatever you use for a drop inlet point. Okay. Or same thing like if you're doing the toe of slope, and then one point is where a stream comes in, perpendicularly into the bottom of that toe of slope and where it joins it. And so that stream centerline point you might call, CLSTRM. So you shoot the one point, and it is, on the one hand, it is the toe of the slope that you've been working on, but it's also part of this other feature, this stream centerline. So you just put a space and give it the same, or give it the code that it needs to become. Very powerful, only makes you, so you don't have to go back and keep trying to duplicate a bunch of points you've already done. So anyway, we'll leave most of these set to be the defaults, where you can, here's how you can treat the different use of multiple codes, and it has some implications back and forth. You can import points from the CE codes that you're using from a data collector, export, blah, 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 all kinds of different things, Civil 3D, CNG, land desktop. So you've also got this little spreadsheet editor, and this is everything that we were just doing before. In that little edit button, this comes up in just an alternate way of editing your codes, etc. All right. So drawing codes without a suffix is points only. So even if we had like EP, we don't have a suffix on EP, like an EP1, EP2, EP3. But if you said, anytime I wanted to create an EP point, I just want it to be a point, but if I want to connect them up together, I'm going to make myself in the field call that EP1 or EP2, and EP2, 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 and then I'll switch over to EP3, EP3, and I would have this turned on, so if it only sees EP, it doesn't draw lines. It ignores them because it doesn't have a suffix. So it's just a different preference on how you want to do it. We're going to leave these again, like I said, set. Set to behave the way these are set up. And you notice this right here, the default distinct point layers. That was that behavior when we hit the edit button, and you saw that come in when we checked it. It put this as a suffix onto the main layer. That's what controls this behavior. You could have put a prefix. You could do whatever you want, or you could just type something at random. All right, so all of these we're going to say is carefully no basic points for. Okay, so all of these by default will leave set to this, and we'll call that okay. And now the next or the last thing I want you to look at is in these code tables, excuse me, what we call special codes. And these are the ones, these are codes that go after your code. Like you're going to shoot a point, you're going to call it a CL, and then you're going to put a space, and you're going to put one of these codes in there, presumably, once you're used to surveying by field to finish. And so you would say, okay, my CL is the description. So that's going to automatically start doing things like my code says. But I can, within all of these CLs, I can put a space BEG. This is, all right, this is going to begin a new centerline line. And I may have other CL points, but I'm going to, if I see a CL space BEG, that means stop what you were doing on the old CLs and now start a new centerline line. Same thing with an end. It's a good habit to get into when you first start. doing this work is that you're going to always identify the first shot in a feature and the last shot, so you know where it starts and stops. And then there's the PC and PTs. Those are the two most important codes that you're going to see, and that's these next ones down. That's where the start a curve and stop a curve or end a curve. So PC and PT, and they can be anything you want. You know, you could put SC and EC, it doesn't matter. You could put 7 and -7. Again, none of that stuff matters, just as long as you're consistent with things. But there's a couple of ones that you want to be familiar with is begin and end, PC and PT. And then you've got CLO, which will close a figure, because remember, you are out there on the ground in the field. You're basically drawing a CAD map, and it's just like typing C to close a polyline, right? And then you've got this near code. That means you're going to find the nearest one of the same code to join to instead of go in sequential order by numbers. There's a rectangle code, so you can shoot, say, 2 edges of a rectangular feature, and you give it a rectangle code, and it will draw it, you know, to the right or to the left with an offset distance. You can also shoot 3 corners, let's say 3 corners of a building, and if you say rect on the 3rd point, it will form a rectangle out of, you know, the remaining 2 sides. It just reflects them from their work. Okay. Then you got offset verticals, horizontals, and that's the way you do a lot of curb lines and things like that. So you shoot the face of the curb, but you're going to offset, you know, 6 inches up or down or left or right, and all that kind of stuff. You got this. Here's another one that's very popular, is join to point number. So even though you might be doing, say, a power line between power poles, you shoot one pole and you say, all right, well, this is the power pole where the power drop comes off this pole and it goes over to this building over here that I've surveyed. It's got a point called BLDG and it's point number 126. Well, you're going to do, you know, a PP for a power pole and PP. And so it's starting to draw the power line between all the power poles. And you get to the one PP that does connect, and you would say PP space JPN, and you give it the 126, whatever that building corner number was. And you're saying, even though all the PP codes are drawing the power line symbol between, you know, power pole to power pole to power pole, when it hits the one that says JPN, it just shoots a line over and connects it to whatever point number you said, and then keeps on what it was doing. So nice little extra little controls. We won't go into trying to learn what all these means today, but you've got circles, you've got sidewalk ramps that you can do, all kinds of things there. You've got up here in these upper left, you've got some controls, and this one is pretty common. This / character, that means to append the description, and that's a way that it just adds some additional text into the description in the drawing. And that's useful for things like if you shoot trees, you might have a code that says, you know, you shoot 8-inch trees, 12-inch trees, 18-inch trees, and 24-inch trees, but sometimes they're pine, sometimes they're oak, sometimes they're elm, whatever. And you would have a code that says, you know, 8 or 8 IN for 8-inch or whatever, that whatever you capture in the field, you would say 8 IN space slash, and you put the slash in there, and you would say oak or pine or elm or whatever you're doing. And so your code 8 IN says, write out as a description into the drawing 8 space INCH space DIA space, and then the slash OAK would say, once I see the slash, I know there's additional description, and it's everything after the slash then that gets written into the drawing. So again, we're not going to be concerned about it right now, but that's how you can really finesse your work out in the field without having to make a separate code for every individual instance. You make a generic code that covers the category, and you use a lot of these appending type controls. Okay. Rotating, sizing, etc., etc. You can have a photo link down here where you can link to a, maybe your survey instrument has cameras on it, or you can take a separate picture, and so you can go back and find things, with some photographs that are tied to the point, all those kind of cool things. But anyway, the biggest ones we want are begin and end, and we want PC and PT. Now, when you shoot curves, and we won't have any in this one, you go to the point that is the start of the curve, and you call it PC. And then you get at least one point in the middle of the curve. You don't have to, but you have to have a couple of other things. But the next points that you get, at least one, and it can be more than one, it can be as many as you want. You just go back to calling them EP. You don't say EP POC, like point on curve. It knows if it's between an EPPC and between the end of the curve that says EPPT, any of the EP points that occur between those two markers are understood to be on the curve. So you only need to identify the start, and you only need to identify the end of the curve. And if you should happen to leave off, say, the PT, it knows to stop it after 3 EPs. So an EPPC, the next 2 EPs will define the arc, and then it goes back to being linear if you don't use a PT. But that's one reason I like to always say PC and PT, even though I don't have to have them. Same thing is true with begin and end. I don't have to end the line, because the next time I do a begin, it's understood that I've ended the one I was working on. But I like to specifically state that when I collect my points, because out in the field with field to finish, once you start using that, you're going to start thinking in terms of you are drawing a map out there in the field as you go. And that's what you're doing, things like this. And you're going to start using codes like close. You're going to begin and end. You're going to start your curves and stop your curves, and you're going to see them show up on your data collector and all of that. Okay. So soapbox lecture off. I'll say okay to that. We're going to take those and see what happens with this. We'll save our code table. And now we're going to come over here, and you can either say exit, or let's go ahead and hit the draw.
Wait a minute. Before you hit draw, let me point out something.
Okay.
On the center line points.
Okay.
Aside from the center line points I got along the road here, I got some center line points down through here that really don't have anything to do with these center line points.
Okay. I'll show you exactly how we're going to handle that. And that's an excellent thing to keep in mind. And the way that we should have done those is, normally we would have said CL, 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 CL down this edge. But when we start putting their center line points out here, we would say CL1, CL1, CL1. And we could do them.
I know which point numbers they are, or I mean, I can identify them, which point numbers they are. We could go through and change those if you want.
Yeah, we can do it. But what I want to do is run this thing through the first pass and let you see what happens, and then see how to fix those. But like, you can, one of the reasons you do that CL1 is you could, and it depends. If you shoot all of these CL points out here in the road before you shoot all of these, you could just say start and end, begin and end. And then you come back here and you say CL begin, then this one's already done. So it won't include those and does these others. However, if you said you did a center, a center line begin out here, center line, and then before you get to the end of this one, you decided to start shooting a few of these points, and you said, center line 1 begins, center line 1, center line 1, and then you come back over here and you pick up where you left off. You go back to calling those center line, end. So CL is different than CL1, but I only needed one code to do it. That's that suffixing that we're going to look at. Okay. But, and again, we'll see how that part is to work. Once we see where the points lie, we're going to get a really good sense of how this is going to work. Okay. Because this will be a multi-pass thing until we get it resolved and refined. So we're going to say draw, and it's going to come to this. And this is what normally shows up, you know, if you have a code already, when you go into this command, this comes up first. You don't go into that, you know, build a table from your points, etc. But you see that it's already knows what coordinate file, it knows now what code table. If I were doing GIS tracking, I would have a separate file for that as well, but I don't. And now my range of points, and again, you could say all, but then it would start drawing all of those other little non-coded points, like these property corners and everything else you've got in that list of points. Or because we made that group of points, that topo group, we're only going to draw the topo group. Okay. These other points are going to stay as they are. And we'll tell it all of the different things we want to draw. In this case, we'll take the ball, and you can filter or restrict your drawing range. You can, and we do want to say erase any existing field to finish entities, because once we draw it once, we see, oh, I got a problem. I'm going to fix that, and I'm going to reprocess. It will take care of erasing those and recreating those. And so that's what we're going to want. But now, the one big thing we want to look at here, and generally it's just to match your surveying style, is this additional draw options. And there's all kinds of different controls and things. I'm not gonna worry about those, but I do want to do this. I want to locate line work and points on my real Z axis. You can say by code, in which it looks at the code, and if it says in the code to do so, then it will, and if it says to don't, then it won't. I generally put mine for my points. I always have that on, just because I like to see my points where they happen to be elevation wise, but none of that matters because the codes all say to do that anyway. So that'll be fine. But right here is this PC to PT curve. Remember I told you how 3 points define the curve? That's this default behavior of sequential arcs. So if I start with a PC, and then I have an EP and maybe another EP and an EP, however many there are, and then I have an EP PT, it treats all of the points, it generates enough, it needs 3 points to make an arc, and then it goes to the next 3 points and makes an arc, and the next 3 points. So it makes a series of arcs. So you can even do curves. They don't have to be arcs. They can be S-shaped, and they can be all kinds of different things. You can start some kind of curved feature. You're just going to start it with a PC. You're going to end it with a PT, and then you're going to get a bunch of points all in between, and it will snake its way in between those 2 points. Either using a Bezier curve, which is sort of a weighted type of it treats the points you shoot as control points instead of points that are on the feature. It makes for a nice smooth point, or series of arcs rather. Sequential arcs will do just like I said. It takes every 3 points and makes it a true circular arc. So you're going to get some arcs that are not tangent to the one before and the one after, and it will be barely noticeable generally, but it could be, you know, pretty severely noticeable if it's not, you know, if those arcs truly are not tangent. Bezier curves, by the way, all of the little curved segments, they are by definition tangent to the prior ones, but they're sort of like a spline fit, if you know what that is in terms of the polylines. And then there's a best fit, and that will do, if you do a PC and a PT, it will best fit by least squares analysis a true circular arc between that is the best fit through all of the points, starting with the PC, all of the points in between, and then ending with the PT. So if it is truly an arc, sometimes that's what some people like to use, is to do the best fit that goes through the most points. But remember, you can also do things that aren't arcs. They can be S-shaped and all of that. So that would not be a choice that you would want to use for that particular type of curve processing. And then you can tell it to adjust the PC and the PT point locations to force these arcs to be tangential to the incoming and outgoing tangents or any adjacent arcs. You can basically tweak that little location up by a particular distance. Over here, it's by default set to a foot. So wherever you've said your PC and PT, and say, all right, move that point as much as a foot to be able to make the points in between in the curve to make them tangent to my incoming tangent, etc. I wouldn't necessarily worry about a lot of those kind of things, because when you're out there surveying those, you're going to be pretty visually close to where the arcs start and stop. So, but when you do this, it actually moves that point from where you're surveying. That's the part that I don't predict. Actually, it doesn't move the, excuse me, it doesn't move the point. It just moves the line work as to where it starts and stops the arcs. So, you know, use that as you wish. Doesn't hurt to have it, but if you ever wonder why, if you've got that on, if you see some arc processing that doesn't exactly line up with the end of the incoming tangent and it's off a little bit, that's because that is checked on. Now, you can again create point groups based on the code definitions, or you can have it automatically create a group based on the code. So all of the EPs, you're going to now automatically, in fact, I'll go ahead and do that one just to show you what it will do. Don't need to worry about it. And we'll say, okay. And now we're going to just say, okay, and let it draw. Now there's going to be some mess once it does it all here. So we've got everything done. Now let's take a look real quick at our point group manager. And remember, we had topo, that was it. But these are the codes. So these are all the toe points. Those are all the spot points. Those are all that EP, P, ent points, EPCL, best entrance topo. All right. So now we've got these points in here, and you can see these points. Now I've got some like this one. Let's I'm going to do some I've got some elevation layers here, but it's so dark on the screen. I'm just going to change their color so I can see them. And I want to make my 3D break line. I'm going to make that one magenta just so I can tell. All right, so now, so you see all of our lines. Looks like it's drawn lines between all these points, some possibly correct, some possibly not. And looks like they're all the same. It's all purple, the magenta color. But remember, we said all 3D and 2D. So if I look at this, I'm going to just hold the shift key and spin it up a little bit. You see what it did? The 2D ones are down below. And there now is that one. So I'm going to go back to plan view. And there is that. Now, if I choose, let's see, this is going to, I've got those edge of pavement and center lines. I wanted to take that B road center line, and I'm going to make it a center 2 line type so you can see that one show up. All right. So that's that's what we have to start to work with. Now I can look at this and see, for instance, these, there's the toe slope, right? So that looks to be nicely defined, right? And there's nothing else that needs to tie to. These points here, now notice, see, this is a point, but remember I turned the symbol off and the description off. So really all you got is that little itty bitty point. So if I want to look at that point, I'm going to double click one of the attributes, so it brings it up. So there is a centerline point. There's the CL, and it's connected to the previous CL, which was 341. Now this one is also connected to this one over here, which was what, 321. Oh, no, not 321, but 320. Yeah, 320 is a CL. So it went 319, 320, and then the next centerline point it went was from 320 up to 341. Now, remember what you just learned on these processing codes, like begin and end. What would you think might be a way to keep this line here from happening?
Put an end on the one up at the.
Yeah,
Right.
exactly right. And I would, just for form's sake, I would also put the begin on the one up here. So this 311, is that my first one that you shot, the center line?
Probably.
So I would put a space, BEG, and I'm putting it in the coordinate file description. And then when we reprocess that, it will read that accordingly. I'll come down here now and take my 320, and I'll put the END. Now, again, if you're doing this out in the field, once you're used to doing this, you're going to know when you do that, and you're going to type on your data collector CL space END, or choose the button that represents ending a feature line.
Were those center line points? They were, weren't they? Okay, yeah, then
320
319, 320, those are
center lines. Yeah, see right there.
okay. Okay.
Now, and then this
What's
over here,
300?
that's an EP.
300 would be EP. Okay.
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 Now here's 321 as an EP, but you notice it goes up to well, you had 322, 321, 22, 23. But what see, so this line over here, that looks like one of those straight closing lines, like this one was for the center line. So we would take a look at, see, there's one, that EP referred entrance. So let's see if we can gather a couple of things to figure out here in terms of like these where we're going to start and stop. So let's go back, instead of trying to do this just piece at a time. Let's go back to survey, draw field to finish, and this time let's edit the codes. We're going to say, although we're going to leave the codes alone, but while we're in the codes over here on this side, I've got access to this edit points. Now, here's where you're going to be able to use your knowledge of what happened out there in the field and whether or not we need to change any of these codes. So you know that you started down here at 0.300 as your first sort of forward, except you had this one point number 2. That's fine. So I don't know where that is in our sequence, but that's going to try to draw from 0.2 to wherever our first, here it is, our 0.311, except we put a begin in there. So 0.2 is no longer connected to that one.
That actually, I guess, should, oh no, okay, yeah. So the one above it, the 310, should be an end.
Yeah, for the edge of pavement, but for the
Yeah.
center line right now, to where that point number two, does it go to this point and then the next one, or
Uh,
see
I,
where
I need
is,
to,
yeah, where is point two in our list of points? Do you
point
remember?
two is up at the,
Up at the start?
yeah, you can't, it's up there. It's right in the center of the road across from the property line that comes in.
Okay, so it would be the furthest center line point.
No, I think I shot past the property.
Okay, I see. All right, so let me close this and exit this for just a second and cancel. All right, so let's go up here and find. So you've got there's your
Right
point
there.
there. Okay, so that's going to be right now it's a center line point, and when it processed, it went from here down to 311 to 12 to 13. But you've also got here's 12. So it went from 2 to 311 to 12 to 13. So that's
Okay,
why
so
it's doing that
looks
double.
like two needs to be eliminated then maybe.
Yeah, well, except you can do one of two things. You can say you can give it a different code, or you can take it out of our topo group. Except I really want to use the elevation it provides. That part's okay. So let's just say we'll keep it a center line, and we'll call a center line, say, opposite property corner, something like that. It is a center line point, or here's another something to consider. Maybe this is an even better approach. Point number two jumps up to 311, then goes to 312, and then to 313, and then 314. So point number two, if we were doing those in order, would be instead of 313 to 314, what about if we did this? If we changed the number from 313A, 3.2, yes. And so now 311 is going to begin the center lines, and that should say BG, and it's going to go to 12 to 13, and then to 313A, and then to 314. Okay, so you see what I did there. And if I'd had these as like 301, 302, or three, or say 300, 305, 310, 315, then I'd have empty gaps, but I didn't have any, but I can use letters, to make point numbers behave correctly there. All right, so I think we've taken care of that one. Although you need to remember that you've now changed the number of point number two. So if we go back to our field to finish, we edit the codes and now edit the points. We're going to see a point. See, point number two is no longer there. We're going to come down here and find a 313A. I'm actually going to come down here in my notes part, and I'm going to say changed to 313A, old point number two. All right, just for documentation.
Okay.
Oh, it looks like it puts. Yeah, does it automatically convert those? Yeah, it does. All right. Well, that's okay. He just keeps it, it has to keep it as a single string of text apparently. So, all right, so that's all right. So that was our 313A. We know that it had that, but it's now part of that centerline sequencing, and you see right where it falls, so it's going to go connect correctly. All right, so starting back with point number 300, we start off with an EP. So that one's going to be our first EP begin. And now, does it go like 300? Do you go all the way down one side of the road, or do
Yeah.
you?
No, I go all the way down on one side. I went
Okay.
all the way down on EP, and then I came back on the center line, and then I went down on the other EP.
Okay. So we get down to this 321, I think it was. So 300, we went EP begin, went all the way down, and we'll take a look at these 2 points here in a minute. And then we go down to this EP right here, and that's the one that we need to end.
Yeah.
And again, that's optional because the next time you get to an EP, you could have just said begin, and that would have turned that off up here anyway. But again, best practice is let's do it like we know it to be. And this was the end of the EP here, correct?
Yeah.
All right, then toe. And again, we had no conflicts there. It's pretty straightforward, but this again, just good practice. And but you also see, I hope you can figure out that as we start and stop these different features, we can you can shoot all kinds of points in between. You don't have to shoot all of the like features at one time. You just, once you start shooting them, they're going to start to connect themselves, and you can get anything in between: a manhole, a tree, a fire hydrant, a fence post, and then go back to picking up the edge of pavement, and it goes right back and it will find the previous edge of pavement and draw the line work to it if it needs to do that. Okay.
Okay.
So now we've come down to the end of the toe. We've ended that edge of pavement, the toe. We've got some spots. We've got this best interest with entrance, which is not coded for anything at this point. And here's that center line. You got 4 points, looks like.
Yeah.
Yeah, so 4 points up into the field. So this would be your begin and your end. And that's basically it. We'll hit the little save icon, the picture of the diskette, which nobody under 35 remembers what a diskette is. And so that's done. We save. And now we just hit the old exit button here and choose OK. And it's going to erase all the other stuff and redraw it. And so now you see that line is gone. All of these double back lines are gone.
Yeah.
We connected those. Now, the other possible question you might have had was that when you had this before and you had this extra line drawn in here,
Yeah.
why can't you just do something like erase polyline segment and get rid of that? Well, the answer is you can. You can do that. If your field to finish produces something that you need to just edit, well, you can certainly do that. Okay, there's not a thing wrong with it. It's just this way, once you know how to fix these and what the coding should have been in the field, then you can take care of doing that, by code.
But if you just did it that way and then you went back and reran it, it would put it back, right?
Exactly right. Good. I wanted to make sure you would pick up on that, and you did. And that's exactly why you do it. It's the same thing about when I teach people how to edit surfaces. Everybody wants to go through and start editing triangles, if they got a problem with this. And I'm saying, you could do that, but what happens if you have to recreate the surface? Now you got to remember which triangles you've edited and go back and redo those triangle edits. Why don't you fix what caused the triangle to need to be edited in the first place? And then you don't have to worry about it. So yeah, it's a great difference in appreciation. Now, what do we have in our work so far? We've got I'm gonna just grab some things by crossing, or in fact, actually, let me do this. We turn on. What was that? It was this Platt Roberts, and you got some control points too. Let's see here. I'm going to turn them back on. So you've got some other points, okay? Now, and you got a control point up here, etc. Now, we got a bunch of points that we shot down here for the field. But my question is, are these points actually points that were shot on the ground, and
No.
therefore their elevations are good, or no?
No, those are, except it's not 204, it's 7. It's
Yeah.
not 203, it's 9. It's
Okay.
not 201, it's 11, 13, etc.
Yeah.
The ones on the other side I haven't gotten to yet.
Okay. So what I'm saying is that these are points. So let's take a look at what we have. I'll just grab some of these things. Maybe I'll grab this one too. Oh heck, let's get those. Yeah. Okay, we'll get them all.
Then there's another control point, the green one there, right there.
Yeah, I think I'd already grabbed it. Yeah, there it is.
Okay, yeah, okay.
All right, so now if I look at this in my 3D viewer, here's what I have. And I can ignore zeros or not. So, all right, so apparently this boundary line is drawn at some elevation. It's probably flat, but it is non-zero, apparently, because it's still showing up. And I see a couple of things here. I've got a point down in here and a point here. All right, so, and I'm not worried about trying to resolve that. I'm just showing you that there's several things you can do. You can use these points that are out here that you've created as part of your terrain model, as long as they were done on the ground. But now look at this right here. You see how those boundary points are up in the air over the ground points?
Right.
Well, that's probably then a good indication that we should not use those points to help us model the terrain.
Right.
It also should be something that we want to make sure we know why they have a different elevation. And it could just be arbitrary. Because again, I think if we, I'm going to exit that now and come back and just take a look at this, because it is 2D and it is an elevation of 484.61. That's probably the elevation of one of these particular points. And it could be when you started to draw that line, you snapped into that elevation as its starting elevation, which is one of the choices right here, is to set the elevation by the first point. But, when you're drawing line work. So anyway, you can resolve all that independently. That I just wanted to look at that and see, well, it looks like those points are not going to be ones we want to be using. So I'm going to go back then and freeze those, the Platt Roberts points. And I think I can freeze. That one as well. There's another point up there, but I'm not going to be including those. So now really the only thing that I'm going to be using to model is going to be, I'll go ahead and select the line work just so you can see it for reference, but we're not going to be using that. So you're going to have everything you see down here is going to be able to generate a little terrain model. And now one thing you can look at right away, what do you see there?
got a center line crossing over to the edge of pavement.
Well,
Oh,
it doesn't cross. It's just sticking up in the air.
Hmm.
So it could have a bad elevation for whatever reason. So linearly, it's okay. It's just got a potentially bad elevation.
Yeah, I would say it is a bad elevation.
Okay, so and then you could go back. Oh, I didn't mark which one it was. Let's see if I can find it here. So it's that one, right? There, I'm just going to draw. Straight point. Boy, I wish they could get that resolved. But anyway, all right. So I drew this little. This is just my marker that I drew in 3D space as to which point it was. And if I look at that, well, that's that EP for the best entrance, but the point that is here, I've got EP best entrance, EP PENT, so proposed entrance. So those are individual points. This would be, that's my center line point. So 435, 337. So a couple of things we can do with that is that we can mark that point to not be used for elevation, in which case it's going to just interpolate from the previous to the next one beyond. Or if you knew, like if you went back and edited your raw file and you say, oh, I forgot to adjust the HI, so you can recompute all that. But I'm guessing that information is possibly lost to us.
It's not lost, but I didn't change the HI, so there's something wrong with that point. It's a bad shot for some reason. It's
Yeah.
pretty significantly off too.
Pardon?
It's pretty far off too, looks like.
Yeah, in height, you mean? Yeah.
Yeah.
Because this one is in, it looks like 10 feet off. There's 25 to 35 and then back down to 28, 29.
Yeah.
So, my guess is it could be 425, 34, but we don't know that. So here's one at 423 to 428. So calling that 425 would probably be okay. However, you didn't edit the point by any reason.
No.
Pretty sure. So something generated that to be 10 feet higher than it should be. Now that's a possible. If you updated your HI and you accidentally hit a 1 in front of the.
No, I never changed the HI.
I see.
Let me look at the points file here real quick.
Okay. At the raw file. Up to there, 1 there, I go.
Let's see, what date is that? What point number was that? That wouldn't be it. Three, it would be here.
One of those CLs there.
Okay, remember what number it was?
No, it was a 435 elevation. There's a 430, it looks like 316. I'm not sure that it, so it goes, no, I don't know.
Let me go back here real quick.
Yeah. Just double click. Yeah, double click the 435.34 number. Yeah, just double click that. It'll tell us 316. Yeah.
316.
So the
316, yeah,
316.
there's something wrong there.
So we're
That's,
from 21 to 35 to 32 to 37 to 41. So
let me look at another thing here. Uh,
so you don't have the raw file, do you? Oh, I see. Yeah, so it looks
what's
like
it again?
316. It looked like your three before it are flagged red for whatever that means, and then 16 it looks.
Huh, well, 316 passed the,
Yeah, the confidence test or whatever that's looking at.
yeah, but clearly there's something wrong with it. That makes me a little nervous.
Well, the 313, 14, and 15 show up as having failed, or they show up red. I don't know what your reports are indicating.
All that means is that the horizontal distance was greater than, uh,
I mean, is it back computing something that it's comparing it to? So that's the spread there. So your horizontal looks okay.
yeah.
Uh,
Anyway, I would
so,
say we probably just need to eliminate that point from the model.
yeah, so we can do that a number of ways. So if you double click that point again, that 435.34, right in the lower left, right there where it says non-surface, click and say okay. Now we've taken care of the point, but we need to resolve this vertex right there. That vertex needs to go away out of the 3D. Okay, so now you see this, well, the point is still there, but I want to, instead of that being raised up like that, I want to get it to pop down. So you can do that a number of different ways. You can edit the actual, well, you can't because you don't have the civil tools, but you can do it this way. You can take out the vertex itself and it will connect the previous to the forward. Or now what happens there is that if there's any deviation horizontally, you're going to miss that deviation. So what you really want to do is, instead of taking this vertex out completely, you want to use its horizontal location, but you want to take out the influence of its vertical position. So let me see if I can figure out how to do that with survey. In civil, that's easy enough with the center line, with the polyline editor. But what do we want to do with it here? Let me go back to my plan view so we're not so turned around, and let me isolate this. And all right, so what I want to do is I want to make sure that I keep, see this elevation 21 to 32, and if I take this elevation out of contention, that's going to be 21, so that's going to be like 26 or 25 or 6. That's about what it looked like on the edge of pavement. That'll fix it. But I don't want to just get rid of the vertex entirely, because this point might not be exactly on the same line that In fact, let's just. Gonna go from there to there. Yeah, there we go. So I've now drawn there. There's the line that goes. What was this? All right, so here's our line that goes through our point. Here's the line that goes just from there to there. Okay. So it's the elevation of this point right here is what I want this elevation to be. Because I want to use that a bit. This is so hard to try to think about in survey terms because in civil, I've got a command that I can fix that with. I just basically uncheck that spot and say interpolate from there to there. Here's what we can do. All right, so I'm going to go ahead and take this one out. So let's do this now. All right, so here's ours that we have, we're going to fix. So we're going to draw a 3D polyline. And I'm going to make it yellow just for sake. So now we're going to prompt. We're going to make sure up here in the top that we're going to prompt for the elevation and slope. And we're going to say, okay. And now we're going to go from this point. Now notice how this pops up here because I turned on my point object snapping under settings. Okay, so but that's what I want. So I'm going to go from, let me try this again. I'm going to go from this point. It prompts me down here below 421.4780. I'm going to accept that by hitting enter. And then it wants to know the next point. Well, I'm going to go to this point here. Okay. And it's going to also suggest that same elevation of that point, 435.33.7. But I don't want to use it. So I'm going to type I to interpolate. Okay, so it's going to use the horizontal, and you see this point elevation will be interpolated upon completion. That's what it says down on the command line. And so now I'm going to go to this point, click it, and I'm going to say E for elevation. And
I'm not sure I understand.
Oh, hush, Siri. So it's going to now go back to reading the elevation, that 432.374, and I'm going to hit enter to finish that. And I'll hit enter one more time to finish my line. So now I have this 3D polyline. And it's got, if I sit in that grip and look down on my status bar down here at the coordinates, I see, yep, that's 421.48. I look at the end and I see, yep, that's 432.37. But I look at this middle point and I see that is now 426.85 instead of 430.
Where are you seeing that number?
Down here at
Okay,
the,
okay.
okay, so all I do is I hover over the grip, but you have to let it suck into the grip. There you go. All right.
Okay.
So that is the elevation that I want to set this, and I click the red one. That's one we want to change. I want to change that elevation to match that same elevation. Okay. And so there's the easiest way to do this is with grip edits, but because it's 3D, we have to rotate it around a little bit. So I'm going to go up to my view, my 3D viewer, my 3D view, drawing viewer, and I'm just going to do a little crossing window on those in that little area. And I'm going to say, okay, and this is going to bring this up. Now I'm going to position this viewer I'm going to sit here and I'm going to push it up like this, and then I'm going to spin it around a little bit so I can see the difference. Okay, so that is pretty illustrative of what I want to do and what I want to see, because I want to take that out and match the vertex that's down below it. So this viewpoint is what I like. I'm going to go to my settings tab, and I'm going to choose this button right here in the middle, this picture that says set the CAD view to the current view. So I'll click that and say okay, and then I'm going to exit, and it's going to put me in that view. And so now, and the reason I have to do this rotated is if I try to do this in plan view, if I do grips and move grips around, it snaps them down to 0 for whatever reason. So I'm going to select each of these 2 lines so that the grips are now visible. And then I'm going to just, in fact, I'm going to talk you through it. I want you to get used to the mechanics of it. So select the red line and select then the yellow line after you click, because you want your grips to be visible. Okay. Now you're going to take your mouse and hover into that one right there. And now that it's snapped, just click your left mouse button and move it down into the grip below it until it snaps. Click. And now you can escape and press, because now you can select the yellow one and also that little cyan one that we drew off to the side, that one, and just delete them both. You no longer need them. Now your point, that 435.34, you see it's sitting up there above it, and that's okay. And we've marked it to be a non-surface point, and I'm not going to change that point. I'm not going to move the point down. We moved the line work. But remember, if you go back and reprocess field to finish, you would have to resolve this again, or you would have to, somehow ignore that point to keep that from happening. But I think we're in good shape. So now let's go back to our plan view, and there's 2 ways. You can go back to your 3D viewer and then just hit plan and set the thing, or you can just type the word plan, or you can go back to the 3D view, or is there a, no, it's up right there. Maybe plan view, bottom one, there you go. Okay, now, so we've got that taken care of, and our road looks pretty good. But look at the, a couple ones to just verify is right down here. We've got this point. There's a point down here. So those are EP points that you see, these grips, and then these are centerline points.
Yeah.
You see what I'm getting at? This center line is real close here. I don't know, should there have been a point in here, or is that an arc, or
yeah, I probably failed to shoot a point there. I should have.
okay, or should that be the PC and this the PT of a curve?
Mm.
And it really, though, Michael, it doesn't really matter, because what this is not, even if we decide later on that we want to draw it as going through this middle point, when we draw the lines, we can fix all that if we have to draw that separately. But what we're doing with this is that this is it's break line geometry. It's going to keep points from this side from looking across to points from this side and making a triangle like that. So now the triangles cannot form across here. They can only go up to the points along the center line. Okay. So those will be okay. Now it will shift the crown a little bit over to the side here, but I think if we resolve this, bring this back over, see, that's getting down toward the corner of our property. I think you'll be okay with that. All right. So now there is, however, one thing that we do need to fix. And that's this right here. Because we have a break line with the toe of the slope crossing this break line, which is the center line, that possible center line that you've created. Okay. Now, we show it as a break line, and that's only because we had that code CL. Really, those could just simply be points. Okay, because for the engineer, they're going to come in here and they're going to design something that may be, let's see, we've got a entrance point up here on these. Maybe they're going to come off and they'll snake their way through whatever it is, but they're going to come down this slope. So they'll have some fill in here until they catch up to the bank on this side. Things like that. So,
Right.
So this line here, even though we called those center line points, that doesn't really need to be a break line unless we're trying to keep points from over here, say this spot shot, from looking over here and seeing this point to form a triangle, maybe.
Yeah, no, I'm not trying to do that.
Yeah, so exactly. So
a center line for
yeah, that's the best alignment. So what I would say to do is let's go ahead, we'll keep those as CL points, but the only thing I need to do is to simply select that 3D break line and get rid of it. And so now there is, and there you can see that the line style. That is a potential centerline plot, but when I model this surface, this is all going to be used together, all these different points. And it's not going to restrict the triangulation. It's going to let them form triangles wherever they need to form triangles. Okay. But with this toe of slope, what that does, and this is an important thing, is that it keeps points like this and this and this from looking across and jumping up here to form triangles up in the air here, because they clearly don't. They have to come to the toe of the slope first and then come up. So that part's well modeled. Excuse me. Well, excuse me. That portion of this is well modeled and well represented, and it's doing exactly what it needs to be doing. Okay. So with that in mind, we can now build this triangulation. Now, what's going to happen though is if we were to triangulate our data, we're going to get a pretty a potentially limited, let me I'm going to set my layer, and then I'm going to I'll freeze off that. So the surface that we're going to get is going to basically look like this. If we were to draw a shrink wrap, cross gaps, topo, that should be fine. And let's take a look at what happens here. Okay, so that was that one. Let's do that again. And then do a I think we're going to find that we need to go back to median. Take this will be, yeah. All right, so that's really the extent of the surface information that we can glean from what you have surveyed. And even if this is being a little bit generous, so I'm saying I'm allowing it to generate to fill in the gaps in here,
Yeah,
saying that it goes from this point at 411.50 up to 413.63 without any severe jolts and joshes. So, and I think that's probably fair to, you know,
well, we'll be able to bring in the state's topo and look at it for comparison.
that's exactly right. And so, so at this point, then we can create that, and that's a boundary topo, and just again, so I can keep track of things visually. So no, that's the boundary, and I've got the break lines. Now the boundary is 2D and it's at 0, so it's not going to cause any problems. So let's go ahead and build us a surface out there. Well, first of all, let's save our drawing. So I did that. It would be a shame to lose all that. And well, let's take a view of this in our 3D viewer one more time, just to make sure everything is in good shape. This is our drawing viewer at this point. There we go. And just select the window around it all. And there we go, hit enter. And then when this comes up, you can maximize that window by double clicking the title bar, or that would do it. Okay, now there you go. Click the mouse and push up, and then go back and grab another piece. There it goes. And it looks like, no, all right. Have I ever showed you how to work this?
No,
Okay. Click over here on the right hand side where those buttons are. You see the one that's the go two to the right. Or maybe one to the left. I think it's the plan view. Yes, plan view. Click that. All right, so that's the way it comes in. Now, here's the way you want to think about this to be able to maneuver. When you have the cursor that looks like it does now, there's either going to be a Z with an arc with arrowheads, or it's going to be an X and a Y with straight arrowheads. That only happens if you use the cursor. If you've clicked over here in the right hand side, the blue cube and the gray circular arrow that's to the right of the hand up here. So those are all different ways. So make sure we're in that, and that's the way it comes in by default. So that's okay. Now, what you want to do is to be able to look at this from any particular perspective is you want to picture yourself as standing in your driveway, and what you're looking at is your garage door. All right. And it's one of those garage doors that's, it's not articulated. It's just a slab. And when you raise it up, it's going to, you know, roll up into the ceiling as a, you know, it's going to sort of cantilever up in as a flat slab kind of stuff. So if you move the cursor anywhere where you're over top of the data in the middle part, you see it becomes XY.
yeah,
But they move toward the edges. And once it gets off the edges of the data, and it's sort of general, it's not exact, it switches to that Z. Okay,
yeah,
so that is when, if you were to engage the mouse at any of those particular locations, it's going to change what happens when you move the mouse. So what you want to do is, the first step is, you're in plan view. You want to go back over the central part of the data, so it says XY only, and you're going to go down toward the bottom, but not so much that you switch. Now click and hold the mouse button, and you're going to just push it up. You're going to try to raise your garage door up into your house, okay? And you want to keep pushing it, and then if you have to let it go and go back and get another bite of it, you can do that, and just push it to where you're at right about, keep going just a little, right there, right in there. You want to be mostly oblique. Now let the mouse button up, and put it down at the bottom edge to where now you can click and hold the mouse button and go left and right, and you can spin it around. Okay. So you line it up and get to where you want to look at something, and then wherever it's all lined up, you point to it with the mouse. Yeah, and now let's say, like, look at the center line of the road. Now let the mouse button up and just point to it and roll the wheel. Okay, and now you can also press and hold the wheel and pan, and you do a little tweaks to fine tune things and all of that kind of stuff. All right, but so that's what we've got, and we're looking over there at the toe slope and the sort of random points behind it, and toward the road and away from the road, all those other spot shots that you took, and everything looks okay. I don't see any extreme outliers. I see a couple of points up here, like there's one right in here that's that one that we fixed, remember?
Yeah.
So, but again, and now it shows up here in the viewer simply because it has elevation, but we've told it to be non-surface. So that point you should see not be included when we model the surface. So you get an idea, and here's here's a spot, that has a little dip in the center line. And that, and it probably, that's, probably truly the case. And you can also, because what's out there, like maybe, and again, like you said, maybe you should have picked up an extra point in here in the center for this center line to be able to sort of be a little bit more merged into, between these two edges. But you'll learn to refine that as you start doing this more and more, and you'll, oh, and there's that 313A. Remember, that's where the property line comes down and hits.
Right.
Which you sort of shot in the center. And so that was, again, there's and here's another example of, if that's the center and this is the edge of pavement, well, you sort of miss the center. But again, those kind of things aren't going to make much difference at all in our modeling. They're just serving as break lines. And if you go later and you need to make a map and draw the center line, well, you can decide to sort of scoot that little vertex over to visually line up in the middle. Once you're drawing 2D line work, that's not going to affect anything. All right, so we've now verified that everything looks okay. We saw our sort of strange point, but we've marked it. So let's exit the viewer. And
This.
yes, either that or the little house down below, either one. And now we can actually make a surface, and then we're going to compare that with the other information. And if we find that it works out favorably, we're just going to merge this into all that additional data.
Okay, so surface,
Yep.
triangulate and contour.
Yes, sir. And now we've got 4 tabs that we need to look at. Okay, so really the first thing and primary thing we want to do with this is make sure that we write the triangulation file. There we go. And we hit the select button over to the right, and we give it a name. And I see that I'm in my McCreary folder, so that's all great. And we're just going to call this, EG at ENT or something like that, EG at the entrance, or just EG. It's just, I would call it EG by survey, or, something that we're going to
What's EG stand for?
Existing ground.
Okay.
Yeah, and so this is going to tell us later, once we make another EG from the state contours, we'll know which EG we're talking about. Okay.
Okay.
So go ahead and save that. And next, we did that shrink wrap. So that's our inclusion exclusion area. So that's there. We're going to say, yep, we're going to use it. And we've got that.
Where is that?
Keep going up. We're just coming down the dialog box. So we wrote the file. And so there we did the use inclusion exclusion.
Okay.
We did the boundary method. We're going to trim the edges and erase the previous contour entities. Let's pull that down and choose all contour entities. And excuse me, we will ignore zeros. That part's good. And we want to densify the break lines. And let's change that interval to 10 feet. And that's just going to add, it's going to help fine tune the triangle points a little bit. And we're not taking our source data from contours, so we don't need anything there. And we're not going to make any adjustments for dense data. All right, so let's go up to the contour tab next. And if you want to see your contours, you can go ahead and at this point, draw the contours. And that's okay. A lot of people like to do that. I tend to not. I like to look, at the 3D viewer and look at my surface, but you can draw them. And then if you have to fix something, it will erase them and redraw. So it's not going to hurt anything to leave them on. Now,
Okay.
do you have any idea what is a good contour interval out there? Is it going to be a 2 foot or a 1 foot or a half foot or?
Well, probably 1 foot is going to be a lot, but some parts of it are flat. But the state contours are, I think, 1 or 2 foot, aren't they?
I believe so, yes. So the 1 footers, and remember, we can change that after the fact always with no problem. So
Okay.
let's take a look at them first of all on the 2 foots and see what we get. So you've got your layers now. Your layers, I would suggest, let's change those up there right where you were, up in the upper right. See that contour layer?
Yeah.
Let's well, you can just, your layers don't exist yet. So I would select that CTR and just type V dash SURF for surface dash CTR dash INT. That's basically the surveyed surface. The contour is an intermediate contour. And we're going to do that contour interval at a 2 foot interval. And we're going to say draw the index contours. So we're going to type that CTRINDEX. We're going to take that same business up the top, but I'll show you a shortcut. Go back to the layer up at the top, select all of that, drag it all the way over, and right click copy. Go down to that CTRX and right click paste, and then change just the last 3 letters to IDX. Or the last 2 letters to DX. Yeah. Right. Yeah. Okay. Now IDX. That's for your index. So there's your intermediates and your indexes, and that's fine. So 2 foot, 10 foot. That's good. We're going to take out all of the check boxes on the left above that. That's good because there's no outliers and stuff we have to do. Any depression contours, let's go ahead and uncheck that because right now, I don't think it's going to show any. And let's turn our contour smoothing method to no smoothing for now. Okay. And now let's go to the labels tab. And let's change that label layer. Again, at this point, I would just paint it, right click, paste. And then change that INT to be IDX. And now put dash TEXT or LBL or something like that. There you go. And now select that whole thing right to left. No, go back where you were. You're right there. Select it all, right click copy. And now again, right there, right click paste. There we go. So now we're going to, if we were to label the contours and the index label or the index contours, if you wanted them on separate label, right now it's all going to go on this IDX label because we're only going to label the index contours. So that's fine. So now let's set our text size scalar is at 0.08. That's fine. And we want to make sure that we label, and the checkboxes down below in the middle portion there, we want to label the index contours only. That's already on. And we want to hide the drawing under the labels. That's done. We want to align the text with the contour. That's done. We want to draw on the real z-axis. That's done. And that's really all we need to do there. And now for the distance interval at the bottom, like every 500 feet, it's going to drop a label. We'll leave it like that and go from there. Now, one thing that you might want to do, Mike, is because these are pretty well what we've changed things to in general. You see there where it says load settings and save settings down below. Choose the save settings. Now it's going to go to your main settings folder, which is where we want this. And we're going to call this EG, or existing ground, or you might put EX, GRD, however you want to remember it. EG space contours, or CTRS, or whatever you want to call it, space settings. You don't have to say settings, but that way you'll know what it is. And just say save. And so the next time you come into having to set up your labels, you can just hit load settings and find that file, and you don't have to change any of that stuff.
Okay.
All right, so now look at the selection tab just once to make sure there are no filters in place. There are none, so we're good to go. We'll say okay and follow the prompts. So the inclusion perimeter polylines, that's our boundary that we drew. We need to select that. We hit enter to finish that selection process. And now it says select entities, but it says select the exclusion perimeter polylines, or enter for none. We have none, so we hit enter. And now select entities, but it says select the points and the break lines to triangulate. So go ahead and just draw a window around it all. Or you could even type the word all in anything outside of the boundary or anything not marked non-surface would be considered. So that now is the contour map, and you can zoom in there around the center line, especially around that bad point. Remember that we had, where was it? We had, it was like a 535. There it is, up there where it says, yeah, right in there. So you see that looks pretty evenly contained between the points below and the point. So it is obvious that it did not jump up. So you see it's showing an elevation of what, 28?
Right.
Yeah, as far as the contours. So that looks pretty good. You've got a nice crown defined. You've got a nice slope defined. There's a little bit of wiggle in the contours, but that's okay. That can be resolved if it needs to be. I think it's all right where it is. And then you've got that, there's a little bit of weirdness out toward the end of things, but let's compare it to the other surface information that we're going to get. So we're going to save our drawing. And let's bring those contours in from the state and see how they compare.
Let's see, was that on tools?
No, it was on the data. JS data. There you go.
Import GIS data?
Yeah, I think that's what we've got, right? And we'll take that from the shape file, the Esri shape file. And by the way, we've been going at this for a good long while. So if you need to take a break or whatever, let me know and we'll come back up. But
I'm gonna have to leave sometime between. I have another Zoom meeting. I've got to go on the Society's Budget and Audit Committee,
yep, okay.
which I'm the chairman.
Yeah, it'd be
Uh,
important to be there for that.
CAD
So,
Resources, is that where it was?
no, I don't think so.
Uh,
WVGIS data all the way down. There we go. Okay, open one more folder. There we go. Now,
You're down at the bottom through index, I think.
yeah, we need to get the index first.
Oh,
Okay.
that's Berkeley County.
Just go back up at the top. You see at the right up here at the top of this list. You see that's Berkeley County.
Oh, yeah.
So it's Jefferson County. And now you can just drag her down, grab that. And now which shape file we told the tile index, so that got it. We'll say open. And at this point, we want the geometry with the data. That should be fine. Same layer for all entities. That's fine. We'll say okay. Let's see where it happens. Failed to get database name. Now, why? Are we in State Plain, West Virginia North? Okay. Oh, I think it's this. I'm start you on the menu here, but go to your GIS settings. You know, it used to hold these, and I don't know why. Well, it's got that. Let's see. Well, yeah, let's go ahead and you can go ahead and choose that McCreary. That's fine. And then for that one, we're going to choose now select and choose the one that McCreary. That's fine. See, I don't think that's okay. I don't think we should have had to have done that, but I'm not sure. All right, so let's go back and do that one more time for the index. Import GIS data shapefile. Select our file. Just scroll all the way down to the bottom, and you can, yeah, okay. Now, let me think about something here. Let's see. I should be okay. All right, so say okay. Now, go ahead and check that first box, although it's not going to have any bearing on us, I don't think, and choose import polylines. Imported 296 closed polylines. Aha. So there we are. And the one that we're in the smack in the middle of, we need to know what tile that is. All right. Now, where is the rest of? All right, so we need potentially these 4 tiles.
Yeah.
So let's find out what those are. So so you can, what we want to do is we want to go to the GIS data menu, and we're going to tell it to, we're going to do the GIS inspector. So we're going to have it float what it is we want to see. Okay. So now it wants us to select the entities. So just go, you want to grab, say, enough to where we're around our areas. Okay. Because we don't need to do all of them. You could, but that's all we need to do now. And we hit enter to finish that. And now, what is it that we want to show? And we have our source, which comes from our database here that we've set up. And we have which feature. Well, we only have the tile indexes in there now, so that's the one we want. And the thing that we need, what was it called? The USNG name? No, it was either that or the zone. Well, I tell you what, let's just do them all. And that way you'll see. So now if you hover the mouse over anything that's been selected, see these weren't selected, so they don't show up. But I look at this, and what I'm looking for is, see, there's that zone 18 letter S, the 100,000 code TJ. But really the USNG name is the only thing I really need. So I'll finish that. I'll rerun the command. I'll select those, and the only one I want, I'll put these all back because I'm just going to get that guy and move him over, and I'll say, okay, so now there it is. So the one we're really after is STJ 6457. Eventually we'll need, oh, this did this same thing. It still says 6457. For all of them, and it's not supposed to. All right, so let's try this one more time. I think what I did was, no. Okay. 6457. Ah, well, heck, let me do all of these as well. So there's, see, they're all saying USNG name 6457. So that's, it's not helpful. Let's see, cell ID 4388. 864 North 57. Doesn't make any sense. I know the GIS data inside a closed polyline. Sixty-four 57. Ah, all right, so let me take a look at the data here. I'm going to import from the shape file. So see with that 6457, we'll just do the one and see where it goes. Okay, I get an idea now. No, that's going to be, yeah, something way down here. So that's why I didn't think that was what we wanted before. So if we uh, yeah, crap. All right, so I gotta undo that. There we go. What is that? That is a piece of in text. So if I do this, 3D break lines, but not the lines, only the in text. Okay, now we're going to do this, select this. All right, so now here's our preferred process. We go to our data, we insert the shape file, we select the file, which is our tile index, and we bring in the geometry with it, and we say, okay. Now, what we need to bring in, instead, we just told it to go for ID. So if I choose the USNG name, that's going to identify that. And so now that's going to come in here. And so now if I look at this, as my inspector, I'll just grab a few of these. We'll say okay. And now let's just look at that. And I see this one is, oh, come on. Okay. Selected those. Sorry. And the feature I needed to get. All right. So now bring that back and this over. Did that work? All right. 5572. You see it's up there in the point ID.
Okay, 5572.
Yeah, and then 5672, and then that should be 5671 and 5571. So 5572 is the one. So 55, 56. So that's the east-west. That's the amount of north is 55, 56. No, that's the amount of east. um, 72, 72, that's the amount of north.
PT must stand for something other than point.
Well, no, it is the point ID. That's just the name of the field that is holding the value. But
Okay.
when we brought the file in, um, like this, and we said, okay, then what it is. So we have two things that we can claim. We can claim the point ID, or we can claim the elevation. These are the attributes that we're going to assign based on the data that comes in. So if I choose the point ID, it's going to look at, now here's all the data. And so I chose the USNG name and it went into my point ID. Okay, so that's how we went up getting that. So now we could even label these, label the GIS data inside closed polylines. There's our closed polylines, and we're going to label the point ID, no field name, just pick it, label, tag, and create table. We'll make it text height. We'll make it bigger so we can see it, and say draw. So now there's your 5572, 5672, 5571, 5671. So let's compare these now with our 5572. That's the only ones we need to bring in. So let's go now to, let me change that GIS import. I'm going to change this to tiles. And we'll make the tiles yellow. That way we can control them a little better. And now let's go ahead and I'll let you go to GIS data and we're going to bring in the contours. So import the GIS data. And it's an Esri shape file. And we're going to select the files. And this time you're looking for that 5572. Okay. And we'll,
Bring
yep.
in more than that at one time.
No, I would just look at this one for now. And we'll say, okay. And now we're going to, what we want to assign is the elevation. So you're going to check that elevation box. And when you pull that down, you're going to choose from the available data points that the shapefile has, one of which is elevation, and that's what we want to use. So it's already set. And then we're just going to say import polylines. Okay. And there they are. And now let's take a look at what layer these come in on. That was on, it's on GIS import again. So I'm going to go and call this GIS import layer again. We're going to call this one contours from WVGIS. And let's make them sort of darker gray, just to keep it from being quite so boring. And we'll take a look and see what we got. All right, so right in here, this contour was at 414. And we have one that's hopefully also at 414. Sure enough, there it is. And you see how it follows that same general shape. Ours followed sort of along those lines. So I'm happy with that fit. I'm looking at This is the 420. We've got the 420, so all that looks pretty good. The contours cross the road fairly well. They don't have this edge of pavement defined very nicely because you see that contour comes across and instead of pulling back
Right,
here, it sort of goes on across. Now so they basically, they show the road as being sloped from one edge to the other and you're showing it as being crowned. Do you remember when you were out there how it actually looked?
it's not very crowned, but it's crowned.
Yeah, it won't be very crowned. There's very little difference right in here, but here they're showing a little bit of a crown, and so they're back to being a crown in shape in here. But like down here in this part, they're showing they've got the crown completely missing right here and right here. It's just, well, you get the idea. You see what's going on, and yours actually reflects pretty much the same as theirs in there. So that's all pretty good fit. And so what we can do is we have our surface. We're going to make a surface out of their data, which again is going to be kind of rough because it's only going to be from the contours.
Right.
Then we're going to cookie cutter our data into their data and then deliver that result
Okay.
process. Now, the extent to which we need to do that is so when you deliver this to the engineers, you're going to need to give them this stuff in here too, right?
Yeah, probably.
Yeah, and they,
Although I don't
oh,
think they're going to go back that far. They're only supposed to go in for 100 feet or so. So really, they're not going to go in too much further than
this.
probably. Yeah, if I give them that, that ought to be enough. I would think.
Okay. Yeah. Yeah, and you know what? Whereas you could give them all of this stuff down here as part of the surface, here's where I sort of draw the line at using that data. That's good for checking and it's good for preliminary work. But for you to deliver to them, hey, here is the topographic survey that almost has a tacit implication that you surveyed that ground out there and you didn't. So they would have to make sure it's declaimed and it says that the source of the topographic information is from the flight of such and such a date for the West Virginia GIS, blah, blah, blah. But the other point is that if they want to get into some real fine-tuned design, you know, you want to try to sell your services to go in there and fine-tune this with additional field work. So you don't want to, point out to them that they can go out and get all this stuff from somewhere else and be done. Because, you're picking up actual real conditions and that's what you want to deliver. So we're going to do that. Now, one thing we're going to do too, instead of like going out here, what is this feature down here? Is it part of the
Floodplain? There's a stream over there.
Yeah, that's what I was going to say. It's something broad and flat. I just wondered what was there. So so let's draw
Also the county line, which is why you're not seeing anything across from it.
okay. There we go. All right, so I'm going to sit on this little boundary layer. Now, what I want to do is I'm just going to draw arbitrarily here on that layer. And I'm going to turn off my snapping for the moment. And I'm going to say we're going to draw just go from here. So right in here, and then I'm going to come up to here. And I'm going to come back to here, close. All right, so I've done this, and I'm now I'm going to offset that through, and I'm going to pick this line, and I'm going to go say this out to there. Now, what I'm going to use this for is a boundary. So we're going to use that as our limits of creating a surface from those known contours that into which we're going to insert our surface that we've already made. Okay. So let's isolate layers. I'm going to isolate this contours from WVGIS and our boundary. We have ours that we can leave on, but we're not going to use it for anything. And so we're going to build a surface out of this. Okay. So let's go to the triangulate and contour. We have to go back to survey, and then you're going to go to surface. And by the way, what time do you need to leave?
About 4:45.
4:45? Okay.
Yeah.
All right. I just didn't want to push you. I didn't want to push you in the name of pedagogy if you needed to get this done.
Well,
all right.
I need to get it done, but remember, we're scheduled also for tomorrow morning.
That's true. That's true. But I'm trying to balance of, I want you to learn the stuff too, because I could do this for you in about 20 minutes and have been done with everything, but I want you to be learning this so that you don't have to call me up every time you get this type of work to do,
Well, this is the first one I've done in 3 years, and it may be the last.
Oh, well.
I don't get an offer to do it very often.
All right. Well, all right. So let's go to the surface menu and triangulate and contour. We're going to build a new surface. And now, just like we had before, we've got everything that's set, just like it was the last time we did it, but we're going to change the name. We're going to go to the triangulate tab, and we're going to change to a new file name now. So instead of EG by survey, we're going to hit the select button.
Wait a minute, I'm lost here.
You're right. You're pointed right at it, but go to the right. Go up to where it says right triangulation tab or file rather. Right up here. See where it says right the triangulation, and then we choose the select button. Okay. And so here's going to be EG by WVGIS. Okay. So that's all we're doing is having a separate file. We're going to use the inclusion. We're going to now erase the previous contours. I'm going to turn that off because I don't want to run the risk of it getting rid of ours. Even though we've isolated the layers, it still will go through and do that if we're not careful. And we're going to ignore zeros. And now this time, I'm going to uncheck this densify. That's not really going to help us a whole lot because these lines are pretty dense. But the big key is right here. This adjustments for source data of contours. I have source data that is nothing but contours. Terrible. That's all I can do with it, though. I'm going to minimize my flat triangles. And that's really all I want to do. So it's going to try to keep any of these places where these contours double back on themselves. It's going to try to keep from allowing those triangles to form flatwise across those. It's still going to let some in, but we're going to just turn that one on. And on the contour and label tab, now this one, I'm going to uncheck to draw the contours because they're already drawn. I don't really need to see them. I just need to make a surface from it and then see how it looks. So if I uncheck the draw contours, the label tab goes completely gray as you would expect because you're not drawing any. So now all I'm doing is creating a surface from the contour data. Again, worst source data you could possibly have, but it's all we got. We're going to use it. We fine-tuned in the area that we needed to fine-tune in. The rest of it, we're going to go from there. And so we're going to say, okay. And it's going to ask us now to pick the inclusion polyline. Now I'm going to pick this red line so that it doesn't use all this stuff out here on the outside. It's going to trim off our surface to that boundary. There are no other inclusions. I have no exclusions. I could exclude this boundary that we did, but there's no need to. I can do that once I do the merge. I'm just going to leave that alone for now. I'm saying no exclusions. And then it wants to know, what do I want to triangulate contour? And I'm just going to do a crossing window across all of those contour lines. And it's going to run through here. Said it skipped edges that exceeded the max length. That's fine. I say, okay. And now it's built the surface. Okay. So where did it go? It's sitting out there in a file by itself. Let's take a peek at the surface file viewer. So this is 3D, this is view, 3D viewer, but this time it's a surface file. And I'm going to take a look at that surface file and we're going to see it in all of its splendor. And let's turn on the contours at every 2 feet. And so that would look like what? Now you see there's, you see how these edges, there's some near vertical edges in there because, again, remember, the only thing we've got to go from are those drawn contours. Now here's a little goofy looking area in here, but that, you know, I'm pretty comfortable living with that. I'm going to also now go to my model tab and I'm going to add some entities, and I'm just going to add, I'm going to add these drawn contours that they had and overlay them on top of my generated contours. So you see my generated contours are yellow, the drawn contours are gray. So even at that, we still didn't exactly match. Still got a little bit of interpolation that it's doing, like look right at this contour in here. So that would be a case where, you know, our contour is not incorrect, but it's just not as correct as it should be, because it does come up to that elevation and it does go way down here to this elevation, but it's doing this weird looking shape. You know, it should be coming around separately. But again, and this one, you know, who knows? So let's try one more thing. If I try, I'm just gonna do this instead of minimizing flat. I'm gonna put this back to say 25. I don't think I want to interpolate these ridges. Now let me see what that looks like for us. Just for peeps. Grab the data. Oh, let's see, crossings. Where did that go to? What? I don't know with that. Oh, I do too. All right. So triangulate. So instead of interpolating these ridges and valleys, let's just do that. Ignore zero inclusion, exclusion. All right. That should be. Whoops. All right. Inclusion. Exclusion. Yeah, let's see. Okay, good. Now, if we look at that surface. Yeah, we still are going to have this long, stupid looking, shapy things in here. So that didn't fix a lot. If we did one more pass now, and let me see what that does. I don't think that's going to be helpful. May have didn't fix that, but it may have cleared up that in there. Let me take a quick peek at. Yeah, it didn't. It cut them off. So we do need to once more into the breach, and this will do us. We do need to definitely minimize the flats. And then we'll just live with those little areas. There's not much we can do with that unless we want to get into the trivialities. Now, so what we have next are these two areas. We've got one surface here, and we've got a second surface that was our survey. And it looks like this as it overlies or underlies, whatever the condition may be. See, we're going to have better definition along the edge. You see all that jumbled looking mess? That's from theirs, whereas here we go. When we turn this off, you see how ours is nice and sharply defined because we had a nice break line down there.
Yeah.
They didn't. Theirs is just this jumbled sort of random looking mess that sort of worked out and so, here and there as it needed to. But so we're going to now, because of that, we're going to we're going to slice in our surface into their surface and come up with a composite surface and see how that applies. So we'll go to our surface menu, and this time we're going to use the triangulation file utilities, which are right here. And we're going to load our tin file. This is our base tin file. So that's this overall one here. And you can see it, you know, just as we were discussing it there. And we're going to now go to the next button at the bottom. And here, again, we can turn this back on and play around with it. But within this, where our controls over here now are, in fact, let me make this not so full screen. All right, so within this now, we're going to merge our 10. So we choose merge 10. And the second 10 is going to be inside the current 10, which has the outside boundary with a transition. And that's, I think, what we want. The second 10 is inside current, says outside with an adjusted elevation. I don't think so. Let's see. The boundary is offset to create a zone where transition between if boundary is missing, the outline of the second 10 is used. Okay, or this one is the boundary is used to add intersection points from both 10s. Elevation of second 10 is held at the boundary adjusting here. I think maybe that's the one we want. Let me see what this one is. Cookie cutter style. The second 10 is taken as inside. The affected outer terms are removed and the gap is retriangulated. Add points of the second 10 inside the boundary. Into the test. Breakpoints ignored. No, we don't want that.
By the way, what does 10 stand for?
Oh, I'm sorry. Triangulated irregular network.
Okay.
It's all of those triangles that get built. So we're going to combine the 10 histories from both 10s of a single data. So, all right. So this is, I think, remove from the current 10 where it overlaps the second 10. Combine and repair the gap. I'm gonna try each of these. I'm gonna start with this one. The transition width. I'm gonna make 5 feet. So my survey. So that now will make that overall everything look like that. Okay, you're still going to have some jumbly over there, but you're going to be pretty well defined. And you got some things up here that let's see if we can get a better result out of these other ones. But for now, I'm going to save as, and I'm going to save this one called EG merged 1 for now. All right, that's saved. And now I'm going to go back to the previous value. And I'm going to merge the 10 again. And this time I'm going to choose this second object. And I'm going to choose my survey. See that did. Yeah, there's your area. It should have the colors. I don't know why. Colors didn't work there, but anyway, we'll try this and see what happens here. All right, we're going to go back one more time. We're going to merge. And this time we're going to remove from the current where it overlaps, combine and repair. Say okay, and I'm going to bring in the EG by survey. All right, we'll save that one as this one, but 3. I think I know what I may have done the last time. I'm going to go back one more time and remerge that second one. or the second time. And if I think I may have picked the wrong file. I think I may have missed that and got the other one. I don't know that. Nope. Apparently I did it the same way. There's something about that. I don't know what it is, but we've got it. Okay, so I'm now going to exit. No need to save any of that. I have 3 different files. If I look at my merged in the first condition, let's look at our resulting contours. Look, okay, I'm a little concerned about this business up here. Not so terribly, but a little bit. Let's see what else we've got. If we look at this second condition,
I bet that's the top of a rock.
and that doesn't look like it managed. So if I take that off, no, maybe it did. That looks like it looks like it merged it okay. Now, what did you notice?
That, well, that little thing,
Oh, that little vertical edge back there is sort of gone.
yeah.
Yeah, so that's, in fact, if I look at, oh, well, I don't have the boundaries shown up there as, now I've got a little bit of one in here, but of course, that's not going to be such an issue. All right, so I'm kind of liking that one for that particular case. Let's take one last look at number 3 here. And that's got a weird looking, it runs the contour all the way up here and around and back down and out. So that's also doing that. It's keeping that little vertical edge. I think this one is our better option all the way around mostly anyway. Let's see. Up there's where that vertical edge wound up being. Now right in here. See, that went from this point here, it shot all the way across to here to connect those up as triangle edges. Now, if I am able to do this, I don't know that I'm going to be able to. If I can add, say, from here to there, I fixed those lines. Get the same thing from here. care of a couple. Oh, God, is up right in there. Be happy with that. So this. Here, here, and here. To say here. This way. So, here. Finally, from here. You may notice I'm not really fixing anything necessarily correctly. I'm just smoothing out what appears to be some problem areas, like right in there's one, for instance, that's probably should go from there to there. Oops. Should go from, say, here. Here. And maybe from here. All right, so I've sort of made a cosmetic kind of fix, and there's a little bit of a little rising peak right in here, so I'm okay with all of that, I think. But the biggest thing that was nice to see was the refinement along the road edge and the TOA slope that you provided. I think that part is in good shape. Let's see if I got, what is that? Let's smooth that wrinkle on it. All right.
I'll tell you what, do you think we could adjourn now and reconvene tomorrow morning?
Yes, sir, I sure do. So let me exit this, and it's now going to ask me to save the surface. I'll yes, and I'm going to call it EG merged. And I'm going to say edited. All right. So
Okay.
that. And let's restore our layers back to this. And we've got the GIS data here. Might as well keep it. You can freeze it later if you need to. And like I said, I think we've got a good enough interpretation. You've got some good clarity here that we've merged into this overall outside surface. We'll re-contour that one once we get that done. Of course, it'll only go out to the edges that we drew out to here.
Right.
And be what you deliver to them, as well as you're going to deliver that land XML file so they can use that file directly.
Right.
And that should do us. So now save that file, and I will end my remote control, and I can stop the share, and I will stop the recording.